Okay, cool. So we'll get underway. So our speaker today is Simon. Simon's a postdoc in my group. He does PhD at Karolinska in Stockholm, Sweden. He's here actually as a Wallenberg fellow. We've had a couple of those come through before. Kian Shaker, for example, did a lot of nice work with Adam. And now Simon's on that same fellowship program, which is a fantastic program if you happen to have done your PhD in Sweden. So very, very, very happy to have had Simon join the group as of last fall. And he's taken advantage of some interesting sort of coursework here at Stanford about open science. And that's what he's going to talk to us about today. So Simon, all you.
Thank you. Yeah, this talk sort of came about talking with Michael Mosley during FICA and discussing these topics. And as Dan said, I participated in a short mini course on open science, which was actually called the Art of Reproducible Science. So it's going to be a lot of stuff from there in this presentation as well. And I mean, this is not what I'm doing here, actually. This is something else. So this is not my research. This is just, yeah, something I think is important. So just a quick outline. So I'm going to present the concept of open science. I'm going to tell some scientific horror stories. I'm hopefully demonstrating the need for open science. I will focus on reproducibility and data sharing. So open science is huge, right? So I'm going to present a couple of arguments, and I hope there's going to be a discussion. I've sort of made 4 main arguments. Yeah, we'll see how those are received. And then I'm going to finish by showing some useful tools that can help you be the change you want. So I'm just going to start with a quote by Sir Isaac Newton, where he says that if I've seen further than others, it's by standing up on the shoulders of giants. And by that, he meant that like what he did built upon stuff that others had done before him. And I think this is even more true today than it was in his time. In his time, you could be like a Renaissance guy, right? You could know everything. Now, like nobody climbs the mountain of science alone. It's a collaborative effort. Funny thing though, actually, some people suspect that he was actually saying this about giants because he was mocking one of his rivals who was very short. But I don't know. Yeah, okay, so what is open science? Well, I mean, what is science? What does it mean for something to be open? It's a huge concept, right? So, and it's a concept that everybody wants to own. It's something of a buzzword. So, and any discussion can risk of like derailing into like just virtue signaling, like, oh yes, we should do this. Like, the talk is cheap, and all these icons that I put there, they all have their definition of open science, right? So there's like all these subcommittees, like the subcommittee of pulmonology, open science committee, all discussing this. So it is what we make it ultimately. So, but I mean, in broad terms, it's like a movement to make scientific research, and that includes publication, data, samples, software, and its dissemination accessible to all levels of society, not just elites, you know. So there's actually been an attempt at a universal definition by UNESCO. So they had a meeting in Paris in 2021, and 193 member states adopted the following sort of like infographic definition. And I don't know, for some reason, the UN seems to like these sort of like infographics. I find it sort of like a bit vague, but what I'm going to be talking about today is probably going to be more about like open research data and reproducibility and some stuff down here. But I think that sometimes it's easier to describe something by its negation, especially if it's a complicated subject. So think about health, right? Health is like famously undescribable almost. What does it mean to be healthy? Well, I mean, it means something like not being in excruciating pain, not having to go to the bathroom every 15 minutes, throwing up constantly. So yeah, so I'm gonna try and talk about what open science is not. So this is not open science, I don't think. So this is what's known as the paywall, right? I'm sure everybody knows about it. So a question to the audience, has anybody actually paid one of these?
Not myself, but from a company.
From a company, okay. Yeah, and I guess we don't pay either. Well, I mean, Stanford pays, I guess, Karolinska pays. But yeah, so this is not open. And so, and this is a breakdown of on the vertical axis, we have the amount of the market dominated by these big publication houses, and how much, like, who gets what of the cost of the publication cost. So Elsevier is one of the big ones. I think these 5 are called the big 5 in publishing, and they sort of like hoover up all the money from Stanford, Karolinska, and your company, I guess. And yeah, so there's a note about the prices that the universities pay for these bundle access to the journals. They insist that the publishers insist that the libraries sign confidentiality clauses to keep their prices secret, because they want that, obviously, because otherwise we can just go to Kedron. It's like, why are they paying that little? I want to pay that little. Like, it should all be secret. So, and they all have like huge profit margins of over 30%. So yeah, so we write the papers, we perform the peer review, we pay to publish, and we pay to read. I'm not sure how that makes sense, but this is a big societal discussion. I mean, I don't think anyone in this room is gonna like stand up to Elsevier. It's gonna be difficult. So what it also is not is, I guess all of you have seen these data availability statements. And this is from one of my papers. Just want to show that I'm not a saint, you know. You do what you have to. So, and these are required by many of the journals. So a couple of guys actually, they sent out a couple of reasonable requests to these corresponding authors who had data availability statements. So 1092 met the, I can't remember whatever criteria they had, but they had to have data availability statements. And only 244 responded. And there were some people who said, well, I'm not in charge of data. It's someone else's responsibility, you know. And about roughly half of those 254 said that, no, you can't have the data. I guess the request wasn't reasonable, or I don't know. And 123 said yes. So this is roughly about, I think, 90-something% that it wasn't available. So, I mean, it's just empty words. What does other people think? So, overwhelming majority seems to think that making research publication open access should be a common scholarly practice. 80% thinks that making research data open access should be common practice. And then open peer review, I won't get into that, but that's also a huge subject in open science. And well, roughly 50% seem to think that the overall system is working pretty well, which is good. But there's also this thing that we are the knowledge aristocracy, right? So 0.4% of all people on this earth have access to scientific articles. And text is not, it's not a physical resource anymore as it was before. Like, you can multiply them infinitely, you just copy, you know, it's, yeah. Does anyone know what this is? What is it? You scared to say? Yeah.
Is that from the site website?
Yeah, it's from the site websites. I guess I can't advocate for something illegal, but yeah, it's an interesting story. This Kazakhstan woman found like a loophole to get all the articles, and she made a big database. And yeah. So just know that we're the knowledge aristocracy. So I just want to spend a little time talking about an argument from authority. So I think this is what we're up against, sort of like, so an argument from authority has the form of a person A claims that X is true, and person A is an expert in the field of X, therefore X should be believed. So it's a claim without evidence. And I think if you're not, well, I'll come back to that. So when this goes wrong, an example is that in 1923, the zoologist Theophilus Painter claimed that their humans have 48 chromosomes. And everybody, he was such a giant in his field, right? So all the researchers after him, until 1955, they just manipulated their counts to match, so that because they expected it to be 48 because he said so, right? And then it was ultimately discovered in 1955 that we actually have 46 chromosomes. So, yeah, so this is from a textbook from that era showing the 48 human chromosomes. So it's just, these things have consequences. So something a little bit more recent. So some of you may have heard of the Duke potty disaster. So this is one of the horror stories. So Anil Puri is an oncologist and a cancer geneticist who showed great result in predicting the response to cancer treatment using gene signatures. And I think a lot of people work on tumor biology here, and I think that everybody can appreciate the clinical significance of knowing what the response will be when giving someone chemotherapy, for example. That's huge. So, I mean, it's so huge that several clinical trials were started. And then how it happened in 2006, he published this, and in September 2009, they said some guy said that we can't replicate your results. We can't using different data. We're not seeing what you saw. And actually, before that, a medical student in his lab had raised the alarm, and he had been sort of shut down by the university, which is a sad story. So eventually, he put the underlying data online reluctantly. And then these guys, Keith Baggerly and this other guy's name, Kevin Coombs, they sort of did some like data forensics and could show that like he had massively fabricated stuff. So he basically faked it, and the clinical trials had started. Like people had received chemotherapy based on his fraudulent results. And then in 2011, the paper was retracted. So that's 5 years, right? Another example, closer to what I'm doing, and perhaps closer to what you're doing, is it doesn't have a name, but I call it T1 mapping gate. And it's this guy from Oxford had a paper where he could use gadolinium-free cardiac stress T1 mapping to distinguish epicardial from microvascular coronary disease. So epicardial coronary disease, that's the typical coronary artery disease, and microvascular coronary disease, that's sort of like a hot topic now. It's people with chest pain, but you can't really see anything on imaging, and nobody knows what to do with them. So this is a huge deal. And it's a funny story because when these results were first presented at Society for Cardiovascular Magnetic Resonance, my supervisor, my PhD supervisor, stood up and said, "That's beep amazing," for which he had to like publicly apologize, and like there was like emails. So yeah, and then later he was vindicated, right? Because this guy had just faked it all. So, okay, so I think that was a question. Oh, sorry. Yeah.
Oh, I'm not familiar with this paper. What did they do? Like, what was the faking? Or
faking was he'd sort of like he'd deleted the results. I mean, it's extremely how do you say it? Not very elegant way of cheating. He just like duplicated patients, deleted patients. So he curated the data, you know, like.
Yeah. I think it's good to show an MR case because I hear a lot, or I guess more recently in like public news sources, like hear more about like the psych cases or the cancer stuff.
Yeah.
But, like we're also just, we like to think we're very quantitative, but there's
Sure.
people.
Yeah. So I like this because I do T1 mapping, and obviously I'm doing cardiac MR, and so this was a huge deal, right? And obviously it's like a bit personal for me because it was my PhD supervisor. He sort of embarrassed himself, and then it's like, what's going on? I wasn't there actually, but
And how long did it take them to catch?
I think it took maybe 2 years, so a lot faster than this Anil Potte guy. Yeah. It's interesting what happened as well because like like this guy Alexander, he like got all the blame, right? So he's gone. But these other people, I don't know what are their that's like an open societal discussion. Like what were their responsibilities as co-authors? I'm not sure. Like do they have to check his data that he hasn't duplicated it? Like how far do they have to go before you say they're without shame? I don't know. Well, okay, so that's the forensic bioinformatics argument for open science, that many of these fabrications have been exposed by just pure statistical analysis of the raw data. The problem is that without the data and the methods of analysis used to arrive at the results, you can't do that. So a paper is just an argument from authority to me. Like, here's what we did, here's how we did it, trust me, these are the results. So my question to you is, you think science ultimately is like a gentleman's game? What do you think? Anyone?
It's really thought-provoking, Simon. I mean, I'd say from the faculty end of the spectrum, like absolutely put a tremendous amount of trust in our trainees and collaborators that what they're sharing with us in a one-on-one discussion, a lab meeting, whatever, is truth.
Yeah.
Right. And of course we ask questions. Oh, that's unexpected. That's unusual. Why did that happen? Or how come it happened this time and not that? So I think we do a good amount of sort of vetting, but at the same time, I don't get into the discrete individual data point for every study that we do. Of course, it's a huge trust network in all of this, and in that sense, there is.
I think so too. Yeah, and I think it's difficult to move away from that because like nobody can check everything, right? But I think that for my forensic bioinformatics argument, I think it's going to be a lot easier if the data and the methods are available. I mean, that's how these other guys got exposed, right? Like somebody, maybe not the reviewers have to do it or the supervisor, but afterwards when people are like, hey, come on, this result's amazing. And then they just go in there with their eyes and they find it's like a crowdsourced peer review almost. I kind of like that idea. So who knows who this figure is? Yeah, everybody. Okay, I wasn't sure. Yeah, okay. Well, is it a gentleman's game? Well, okay, so this is some data from Retraction Watch. It's a website that tracks all the retractions. And you can see that the retractions increase over time. And well, roughly 50% are due to like fraud, basically. I mean, of course, there will be mistakes, right? But I mean, yeah, I think it's problematic to just assume that it's a gentleman's game and everybody is telling the truth. And you may think, well, I mean, these retractions, they're from like smaller journals. Nobody cares. It's not that important. Well, okay, so this is a graph where they plotted impact factor on the vertical axis against the retraction index. I don't remember exactly how the retraction index is calculated, but it's like the amount of retractions indexed to whatever size of, I don't know. And New England Journal of Medicine, has a lot of retractions, high impact factor. So there's a lot of conclusions you can draw about this. Like maybe if you're gonna lie, why don't lie big? Go for the or you could say that, well, nobody cares about these guys, right? So this is just the tip of the iceberg for these guys, but these guys there's a lot of more scrutiny. I don't know, but I mean,
it's funny that you say that an impact factor of 10 is no one cares. Like, I would say that might be true in the below 3 range, that like no one cares, but I do think that there's also a much higher scrutiny, right? They're cited so much more that like there's a lot more. Those are field defined changing papers,
Sure.
whereas. in
Yeah, I think
field
this graph is a bit difficult to, it's hard to interpret, right? Maybe it just means that New England Journal of Medicine, as you say, have better scrutiny. I don't know.
I would think that's a pretty safe statement. I think that there's a lot more scrutiny on those.
I'm not sure how they made that into the retraction index, actually.
Might just be that those like percentage of papers retracted or something like that, but
Could be.
yeah, I don't know like how many MRM papers have been retracted.
I think it's also the fact that the people that publish papers in those top journals from their particular institution or country, they get a lot more money. I mean, you have to remember that scientific publications are usually rewarded with cash or other valuables to the first author. We're not going to get into that today. I don't
mean,
think.
in how many countries is that true now?
Oh, I know in Arkansas it's true.
Really?
Yeah. No.
I mean, you gotta.
I mean, I know it's true in China, but I don't know how many other countries have that same type of policy.
Most of the Asian countries, India, for example, I can't be specific, but I do know that there's the island, the Pacific island, where they actually advertise and have a website about their going rate for a first author publication in something like Cell, Science, or Nature. And it's about $3,000.
I mean,
So-
yeah. I mean, you don't have to think about the cash award. I mean, if you get a publication in New England Journal of Medicine, you get grants, right? I mean, that's the reward. Like, it's not. It's going to make me be able to carry on my lifestyle of, I don't know.
Yeah, so I'll push back on that a little bit. Now,
Okay.
New England Journal of Medicine, for instance, right? Like that's hard to make up something from. Like you need to do a study with a lot of patients. So I think there is the incentive for you to publish positive results. But I feel like in terms of the like just making up a study, that would be really hard to do in the New England Journal.
Okay, so why is the retraction index so high for New England Journal of Medicine? These are things that have already gone through
Yeah,
peer review, right?
I mean, I think you're right that there is a desire to publish positive results. I don't know what the other.
But they're also a higher impact. So if the New England Journal of Medicine says that X causes cancer, that's a much stronger conclusion than my typical paper, which says we made a slightly improved technique that gives us a slightly better SNR.
Sure.
Right. So I think you have to wait. I don't know if that's weighed into this somehow, but those are conclusions that are directly going to form medical decisions.
Sure.
And I don't know if the retraction index takes that into account, but I think that's quite important.
Of course. Yeah. I'm not sure about the retraction index, exactly how that's formed.
They probably just get higher scrutiny, right? Like,
Yeah.
how many people read the New England Journal relative to MRM?
Sure.
That's probably a factor of 10,000 or something.
Yeah, like how much false data has not been retracted?
Sure. We don't know that. Maybe there's like over here, it should be, maybe it's just level. If it was if it all had the level of scrutiny of New England Journal of Medicine, who knows?
I think of those as fairly similar type. Whereas in the Nature Cell Science, that's much more like early stage.
Yeah, but recently, or we can continue the discussion.
Yeah, no, go ahead.
Yeah, so just a couple of days ago, actually, 26th of December, NIH launched an initiative to double check biomedical research studies. Because this is, I guess, a problem. Yes. So this is something that came up during my course that it's just so, I mean, I just have to mention it because it's just so crazy. Like, so gene names, when you sort of like Control-C, Control-V them into Excel, they get misinterpreted as dates. And this is a huge problem in genetic research. So there's actually like a project. Like it's easier to rewrite genetics and update Excel. So here's just an example. Like it's people paste gene names in, and it's like April 1, April 2, April 5. And so a couple and what's funny is that it's still happening, you know, like in 2014, it was happening, about 30% of publications in PubMed were affected, and it's pretty stable. So this is not like the idea of like science as self-correcting. Well, okay, in this regard, not so much. Yeah. And there's also like some other horror stories just because it's fun, you know. So Excel has row and column limits. So maximum rows of blah, 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 and maximum columns. And so there was this huge, well, it was a disaster, like 16,000 positive COVID tests were excluded from the analysis due to this. So you have any, does anyone have a horror story they can share about something going horribly wrong? Nothing? You're all perfect?
That's a great question.
No one has anything? Like something must have gone wrong at some point.
One thing I've noticed is that all of the, you know, the minor details and how the data is done, and what the data really is probably only known to maybe the top 3 authors, and the rest of us that are just reading through it and kind of, okay, does this actually make sense? We don't see the data.
Of course, yeah.
And it's probably the top 2 or 3 that do all of the work. And if you don't spot it during group meeting, which is why group meetings are so important, you're probably not going to be able to catch it.
Yeah. Except like 5 years after the fact, when the clinical trials have started and the results and people are starting getting the drugs and stuff. Yeah.
But I would say in MR, like Brian was saying, that's a harder thing because a lot of these are so like subfield specific.
Sure.
And if you show a technical improvement and someone's not able to replicate it, are they going to go through the effort of sort of writing it to get this sort of retracted, or are they just going to move on to different methods?
I guess like technical MRI research is more safe in that way. Like if someone comes and like I've made graph version 2 and it doesn't work, then that paper is just going to be thrown aside, right? So yeah, I always think from a medical perspective because I'm a doctor. So yeah.
But I think a bigger issue, it's quite timely. Like if you look at ISMRM, apologies to the non-MR people here, but the ISMRM meeting, a lot of the submissions now are some kind of an AI model for diagnosis, right? So now you have a new issue that there's no way this is ever going to be transparent. And somebody says, well, I did 150 subjects and my model found most of these things. And I'm reviewing this. How am I possibly supposed to do an accurate review of this when I have no idea what the basis for their decision is? I have no idea the details of their patient population. And I'm just supposed to expect that this model is going to save the world, right? So I think this is a very big issue facing us because this is going to truly test the system. Because if we thought it wasn't transparent before, good luck, right?
Yeah, I think, yeah. And so that like the black box problem of AI methods, like you don't know, actually, you could be training it on the temperature of the room as far as anyone's concerned, and you can't see it in the model, right? So I guess then it's even more important that you like people have access to the data used to train the model and the actual software doing the training, like the model itself and how to train the model, because otherwise it's, yeah. But are you, Brian, gonna go work through that for an ISMRM submission? I don't know.
Well, that
Probably
brings
not.
up another point.
Yeah.
And I mean, not to get into politics or something, but it seems like the cost of saying something stupid or wrong has gone down over the years. So at some point, there almost has to be a bigger cost for faking it. And you know, a few of us are on the committee, but you're seeing it. You know, people submitting stuff that's junk. There's a cost to it up front. The upfront cost is my time to identify that that's junk, and that's costly, right? So but there's not a cost to them, because if I go back and say, well, you wasted my time, they'll come up with an excuse. So I don't really want to spend my life policing, but that's also something we have to think about is what's the cost of, you know, I understand that there are multiple reasons why you might have submitted something wrong, but where do we go with that, right?
Yeah. And how to hold people accountable, I don't know. Yeah, so there's a.
I don't know if they're to me that sharing of all data is the way to solve or address the problem. Because if everyone shares the data and someone goes to the trouble and effort, it takes money and time to go through data, reproduce it, track down all these birds. You could have used those same resources to fund other science, right? So having all this data out there, putting all this energy and money into double checking it may not be a wise use of resources.
I mean, it's not the only reason we share data. I would agree that, and I'm guessing that's not done that often, especially in sort of sub fields. But you know, the data is used when people do meta-analyses and try to build.
Yeah, but here the argument was sharing data to get rid of fraud. Or
yeah, one of the reasons, and I feel like at a New England Journal of Medicine level, I think it's a different argument than at a sort of technical MR level.
And I think it also sort of filters fraud up front, so that if you're a person working on a project fraudulently and you're told you have to post everything, you're hopefully gonna filter that.
Yeah, hopefully, I think,
yourself,
yeah.
right?
Yeah, maybe just a knowledge of that the data is going to be available is going to avoid fraud itself. Yeah.
I mean, I think the fact that people share data and other people will use it to do their own analysis might sometimes discover that the original paper made mistakes.
Sure.
Because then you might note, and so I've seen a lot of smaller horror stories, but they're all due to human error. And nobody is aware of this, and you make yourself very unpopular if you come into a new lab and you say, "You did this wrong. Look at this error," and then the work they've been doing for months is kind of discarded. But then they do it again, and so you just kind of need to have somebody to point it out. And worst case, that might lead to the retraction of the paper and a reevaluation of the actual data, and it doesn't have to be bad.
So maybe we need to be harder at our lab meetings. I think that once it's been published and you find a mistake, then that's, I guess, too late.
Yeah, if I can just
Sure.
mention an example I've seen, because I've seen a lot of things at lab meetings, you wouldn't notice this. There's this trained people, they know what they're doing, they have instructions, they claim that they've done everything. I did a little experiment once. I worked with heart rate variability, and I would have people sit there for 5 to 10 minutes and do different kinds of things, and then I would calculate their heart rate variability. And I noticed that somebody was reporting correlations with extreme outliers. And I thought this doesn't seem to make any sense. So I went back and I checked their data. And I made a little graph about what the effect is if you, so you have to look at the data bit by bit for each heartbeat. And if something was incorrectly labeled by the software, you have to point it out. So I made a graph of what it looks like when you have one incorrectly labeled one versus two incorrectly labeled ones versus three incorrectly labeled ones. And the heart rate variability is exponentially affected by this. So if you miss checking 3 of the heartbeats in a 5-minute period, the effect is extreme. And then it's very easy to say, oh, these people meditated for 5 minutes. Now their heart rate variability is much lower. And it's just because you didn't check the data well. So this is like, at the lab meeting, the person will say, yeah, I checked it. I did my work, and this is the result. Here you go. So this is something I found in a lot of labs. That's very hard to catch.
It's like confirmation bias in the eyes of the person doing the data collection.
Yeah. Oh, so, not data collection even, just the person that's kind of processing and not careful enough, and maybe rushing it. Sometimes
that would easily show up if the data was available and the methods to analyze the data was available. That would show up when someone went through it. Yeah.
So if other people were trying to use the data for their own purpose, they would see right away, oh, you must have done this wrong. This number doesn't even make any sense.
Yeah. Okay, so you all had horror stories, but I also had one quickly. So reboxetine was an initially approved antidepressant, and then later it was found that Pfizer had been withholding trials that didn't show efficacy. So, and this was a huge thing. They were like the hunt for these reboxetine trials. So which brings me to the coin flip analogy. So what if I told you I had a coin that lands on head 60% of the time, but to prove that to you, I only have to share the result from half the flips. Would you trust me? This is, Felix, you said something to this effect, like publishing of positive data there's a bias here, right? So negative results never get published, usually. And so this is sort of like a funny comic where you put the negative results. So, well, I mean, I think that's ultimately kind of human, like a negative result is just boring. I think it's not sensational. It's not going to open eyes. But I mean, I think this problem is in part solved, at least for clinical trials, right? Because they have to be pre-registered. And so transparency in this case means that you say what you claim, that this is what I'm going to do. This is the result I expect. So you can't do any of this like hypothesizing after the results are known. So there's also a culture of publish or perish, right? So we need to produce, and the number of publications are increasing. So on the y-axis, on the vertical axis, we have number of publications, and then we have time, and then we see the big five here. Elsevier, a lot of more publications. And of course, we're living in the golden age of large language models, right? So we managed to distill a large portion of human knowledge into a chatbot, which I think is amazing. And I think this can bring about good things, like democratizing science by bridging language barriers, stuff like that. Like I'm all in if it can make text more readable and concise for me to read. And if it can help people communicate their ideas to me, I'm all for it, right? But I mean, it can also be a way to avoid plagiarism checks, to be honest, because yeah.
Well, just a comment on that. I'm like using a tool like this to distill something, like to summarize. Mm-hmm. All these models do is guess. Yeah, they're good guesses. So in that summary, it might be right. But these same models can't multiply 4-digit numbers. Sure. So like, I just say it as like an awareness thing. Like, they're just good guesses.
Sure. And what was I gonna? Yeah, I mean, yeah. Let's not forget that the success metric of these things is how good they are in fooling us into believing that it was written by a human. That is the success metric. That's right. So it doesn't care if it's right. It cares if you think it's right. Yep. Yeah. So some people call it the death of the college essay. I don't know. I mean, we'll see, I guess.
Well, that's going to move to being in person, right? So you're going to say you no longer have the opportunity to write this. Right? You're going to come down into the classroom with a piece of paper and pen and write this.
Oh, okay. Yeah, sure. Yeah. That's going to be rough. You're going to be reading a lot of scribble. People are working on the handwriting, I guess.
Oh, yeah.
Yeah. I think that these tools are here to stay because humans are inherently lazy. And I think ultimately that's a good thing. You don't want to expend too much energy, right? So, but we must also remember that these people training these models have a huge power. Like, I wouldn't be surprised if they start recommending me products at some point, Sneakily. Yeah. So here's just,
Simon.
Yeah, sorry.
Sorry, going back to the NIH initiative to double check papers, how is that different from peer review?
I think it's different because, I don't know where I put it. I think it's different such that they're double checking after the results have been published, right? So it's like they're seeing if they can replicate it.
Are they going to pay for that? Would you fund that, or would you fund some new research company?
Oh, apparently the idea is to have like a second independent lab do it.
Yeah,
So
but
you
someone's
just
got
have
to
to
pay.
share
Someone's
your
got to
methods.
pay that other lab, right? So
No, the NIH are paying those.
yeah, well, but who pays the NIH? Taxpayer.
You guys.
So is that a good use of NIH resources?
I don't know. You tell me.
Seems very expensive.
Yeah, the devil's going to be in the details, right? How are they going to do it? Which studies? How big is it? I don't know. Where was I? Yeah, okay, this is just, can anyone, it's highlighted, but can anyone see what the problem is with this introduction? Who can tell me what happened here? Yeah.
They dragged their cursor across the chat window. They went too far, highlighting.
Yeah. Okay, that's good. No, but it's like they of course they asked, hey ChatGPT, can you write me an introduction? And then ChatGPT said, certainly. Here's a possible introduction. Yeah, but this has been retracted, so I guess the system works. Yeah, there's also this. There's a Stanford professor who, and he's like an expert of lying and technology, admits to using ChatGPT in legal filings. And it was funny because what happened was that ChatGPT hallucinated a reference that was later picked up and like, there's no reference like this. This doesn't exist. I mean, it looks like a reference.
That is super common. The hallucinated references.
Yeah.
If you ask it, did you make it up? It says, oh, I'm sorry, this was a misunderstanding. Yes, I made it up.
I think that's getting a little better with retrieval augmented generation, where it's actually sort of searching the internet for.
Yeah, hopefully, yeah. I mean, there's a huge incentive for OpenAI to solve that issue, I guess. And I mean, the tool's not perfect, I guess. It makes stuff up. Yeah, so here's just, this is like old news, I guess, but ChatGPT can be detected in 63% of cases. ChatGPT 3 is, of course, an old model. And this is, they just had some reviewers score they mixed original articles and ChatGPT generated, not articles, sorry, abstracts. And then they had people decide between them. And my question is this good? 68%, is that okay? Like,
Stanford says it's up to the individual instructor in classes, for example, to admit or not how much ChatGPT or Gemini goes on in that class. Okay. And so that puts it on us instructors to like, that these reflections or these essays are probably written by ChatGPT. But what can you do to stop it? I mean, I had a tough time catching students that were using pocket calculators back in 1970. You could not use a calculator in those days. You had to use library. Oh, that's a
yeah. There was this guy at a Swedish university. He taught a programming class, and he put like these hidden sort of like spaces that are not spaces, but some kind of ASCII, invisible ASCII character into the code that was the assignment. And then he just could see that sort of like multiplied back in the answers, which would have meant that they took the assignment, shoved it into something else, got the result, and then presented it to him. So, I mean, yeah, I don't know. I don't know what's going to happen, to be honest. Well, I think this is going to happen. It's going to become a lot noisier, right? It's going to be more difficult to distinguish what's real and what's not. So I think that the SNR of scientific knowledge, to use a term from here, that will likely continue to decrease, right? And so I think that in this regard, open science can be like noise reduction. That's what I hope it will be. It's like open data and reproducible methods can be an audit trail. It's easier to spot fraud. The less garbage I have to read, the better, I feel. I'm not sure about this. We'll see. But I've already touched upon this, I think. Okay, so it's been a lot of fear mongering here, but so let's play Find the Predatory Journal. So, anyone? European Radiology? Real or not?
Real.
That's real.
Real? It's real. International Journal of Radiology and Imaging?
Yeah.
Predatory. Yeah. Radiology.
Yeah.
Yeah, that's easy. Yeah. Okay. This one. You see my mouse? Yeah. Yeah. Wow, you're really good. What about this one?
Yeah.
And these two? Both of them? Great, that's great. That's great. Okay, so we don't have to worry about Predator Jones. Okay, we've already talked about this, so I'm going to skip ahead. So one of the things I thought about when I was preparing this presentation is that, so if given the result, can generative AI fake the data? Because then I think we're truly lost. I mean, even if there is an, can I fake the audit trail using generative AI? What do you think?
Yes.
Yeah.
Sometimes, yeah. So is there a counter to that, you think?
Hopefully statistics.
Yeah, but I think, yeah, but my point here is that, like, if the generative AI is good enough at statistics,
Yeah.
it might generate like stuff that looks statistically valid, is what I'm afraid of.
Good, but not too good.
Exactly, yeah, yeah. I don't know. Then we're gonna need like real world evidence. We're gonna need like the committee actually going to the lab and like, okay, so watching you pipette stuff, and I don't know. It's gonna be, I don't know. This is my nightmare. So okay, we've already talked about this, like, but the bigger picture is that scientists collaborate for results, but compete for grants, right? Collaboration requires mutual respect, trust, openness, decision-making, risk-taking, and the openness is weighed against the risk of getting scooped. And to be honest, why should I share my data? What incentives are there? I worked hard to get this data, right? So this is what's called a collective action problem. So a situation in which all individuals would be better off cooperating and sharing their data, but fail to do so because of conflicting interests between individuals that discourages joint actions. So too many group members choose to pursue the individual profit, careers, I wrote careers, and immediate satisfaction, again, I wrote publications there, rather than behave in the group's best long-term interests. I don't know, is this controversial?
Sounds like global warming.
Yeah, I think global warming is exactly a collective action problem. Like everybody knows that you should be doing something, but then you have to get to work, so you start the car and go. You know.
I think there's counterexamples, so I mean, I think there are people who get a lot of credit for their science because they share.
Yeah.
There are definitely research groups in our field that have a lot of notoriety for having made available huge data sets. That's a very positive thing.
I think so too, yeah. So ultimately, that's what you want, right? So you want, yeah, the joint action is better than the individual profit, right?
So you have to look carefully at why they did it, why they saw through the noise.
Sure.
Maybe why others.
I mean, there's also the fact that if you're the only one that can do something for a really long time, like it's not going to go anywhere. Because that's not scale. That's literally the definition of not scalable.
Yep.
So you are incentivized to somewhat have others start doing what you're doing if you want.
Yeah.
If you want to make it.
I'm going to skip ahead for a little bit, but there's been a suggestion of data authorship has been suggested. So, so here's the primary authors generate a data set, and they release that into the public domain with a digital object identifier. Does everybody know what a DOI is? Yeah, okay. And then so the authors A, B, and C, and then it was just AB who did the data. So the manuscript would have a DOI, the data would have a DOI, and then there's all kinds of permutations of this. So the data authors are A and B, but then the new manuscript is only A and C. So that's two digital object identifiers, one for the data, one for the manuscript, and then all kinds of iterations where here independent investigator comes along and he writes a manuscript, he or she writes a manuscript. It has a DOI where the author is credited and the original authors are credited with the data. So that's, yeah. What are your thoughts on that? Yeah.
Well, I mean, I think data set like papers exist in certain contexts. But yeah, I mean, it needs to be something that I think is more broadly useful to a community that it gets cited. Otherwise, there's not like incentive for the authors to publish a paper for a data set if it only applies to like the one paper it came with. Makes sense. Like in like machine learning, if you like publish a data set, it gets cited 1,000 times because it's public and it's useful for everyone.
Yeah, I know that the machine learning community has done a great deal to. Yeah, I mean, ultimately, if it increases the incentive to share the data, I'm all for it, I think. And yeah, so let me come with a quite bold statement. It's immoral to hoard data. And why do I think that? Well, okay, so hear me out on this, okay? So we have a moral obligation to share. So collecting medical data carries inherent risks, right? Even they're very minimal for contrast-free MR, but still. So if essential insights can be inferred from the data and recollecting it poses risks, I think we should share it. So now I'm just ignoring the whole incentive structure of science, right? I'm just making a moral argument based on you shouldn't hurt people. And what about animal studies, right? We subject animals to procedures and we sacrifice them to get the data. And I think we should avoid subjecting animals to procedures and sacrificing them if possible. So if 100 sacrificed mice is better than 1,000, one researcher can sacrifice 100 instead of 10 researchers sacrificing 100.
That sounds really good, but I think there is also it goes counter to your argument of we need to be able to reproduce the result.
How do you mean?
That I agree that if we can prevent someone sacrificing mice or redoing experiments, that's really great. But the reality is that it's not quite that simple. That them reproducing the study actually adds quite a lot. I'm not saying that's an argument for sharing data. I'm just saying that the argument that second study doesn't need to be done is not so clear cut as you're framing it right here.
Yeah. Okay. So I put this in to be a little bit provocative. And you're right. I'm completely ignoring the whole incentive structure of science, right? But I think there's something to it. Actually, I do believe in replication, as you said. Like there's of course, you need to replicate your results for them to be valid in research. Yeah. Oh man.
Let's hold off on the rest for another session.
Yeah, because I'll be coming to the more positive bits in the end. Yeah. I think also we have a moral obligation to share because how many times will the wheel have to be invented? Like it's a crime against the universal value of efficiency, I think. So it's an argument to share. It's not like we should share everything. Of course, I'm exaggerating a bit here, but
we can argue this over coffee today.
We can do it. Yes, Fika at 3 at the Oval Table.
And we can also do this again. We can have you back in mid-February.
Yeah, I felt that this presentation, it was like when I tried to shorten it. Every time I tried to shorten it, it just got longer.
Simon, that was really great. Thanks for taking us.
What we can do in this team, so thank you.